Hello student, my name is Nimish Prabhakar. I am Assistant Professor at LJ Institute of Engineering and Technology in Instrumentation and Control Department. Welcome to Process, Dynamic and Control lecture series. In my previous lecture, I discussed about the swelling and shrinking effect, or in other words we can say swell and shrink reaction and inverse response. Now in this lecture we discuss about the feed water and drum level control. That means the feeding system of water and drum level control system. So now we start. So this is a diagram of the water drum level control system. Here what is the purpose of this drum level control system? First of all, question occur in our mind. So the main purpose of water level controller is to bring the drum up to level at boiler startup and maintain the level at all time. That means this is a level controller. That means this controller is control the level of water inside this drum. This is a boiler drum, and here we use the level controller to control the water level inside this drum. So this is a higher level limit and this is a lower level limit. So compulsory the water level is in between these two limits. If water levels go beyond this limit, that means higher level limit, then controller will control the water level by using this is a feed water inlet valve. So here it stops the feeding of the water. So at that time the level controller is used, and if water level go very down, so at that time by using this water feeding valve, it fully open, so water level is increased inside this drum. So simply we can say the use of this drum level controller is to maintain the water level inside this drum. Okay. Now a sudden decrease in this level may uncover boiler tube, causing them to become overheat and damaged. That means if the water level is decreased inside this drum, then there is a chance of the overheat and the damage of the uncovered water tubes. The boiler high water level may interfere with the process of the separating moisture from the steam. So within the drum, thus reducing boiler efficiency and carrying moisture into the turbine. That means here we can see if water level is decreased, then there is a chance of the overheating and damaging. And if water level is increased, here the water level is increased, so high water level, so due to that there is a chance of the reducing the efficiency inside the boiler efficiency and carrying a moisture in turbine plate. That means we know the use of this steam, that means the boiler generate this steam and this steam go to the turbine plate to generate the electricity. So here if water level is more in this boiler drum, then there is a chance of the moisture in the steam. So this is also not good. So there is so that's why we require the drum level control system. Okay. Now types of the boiler water level controller. So there are basically three types. First one is the single element drum level control. Then second one is the double element drum level control. And the third one is the 3 element drum level control. So by using these three methods, we can control the water level inside the drum. So we start with the single element drum level control. So this is the block diagram of the single element drum level control. Here we can see this is a controller module and it connect with the feed water valve. Here this line indicate the inlet water feeding system. That means this is a inlet water system, and to control the inlet flow, here we place one water valve. Here we place one valve, and this is a drum level indicator. That means it indicate the it indicate the water inside this drum level, and this drum level indicator send signal to this controller, and here the controller match this signal with desired value signal, and if it not match with the desired signal, then it open or close. That means it regulate the water flow inside this drum. So this is a simple diagram of the single element system. Now we understand more. This consists of a proportional single element coming from the drum level transmitter. This signal is compared to the input set point of water level, and the difference between these two is deviation value. That means here the signal is compared with the desired value, and we know that if error signal is not 0, that means there is a deviation. So this signal is an input value for the controller, which will generate the corrective action in the form of proportional output. That means this controller generate the corrective action to control the water level. That means here it open or close the valve by sending the signal. So the output is then passed to the boiler feed water valve here, and then adjust the level of feed water flow into the boiler drum. That means this controller output is sent to the feed water valve, and this feed water valve adjusts the level of water. That means it adjusts the flow of water inlet and inlet. Okay, so this is a single element system. So here there is some limitation of the single element system. So first limitation is a single element water level control system is unable to control the level in big boiler. That means it is not suitable for controlling of the big size of boiler. Then second one limitation is the possible inadequate control option because of the swelling effect of the boiler. So this is the two limitation of the single element boiler control system, drum level control system. Now we discuss about the two element control level system. So here see the diagram of the two element control level system. So here use the two element. First one is use the drum level controller. So here is same as using a single element, but additional to this, it also measure the steam flow. That means this is a steam flow measurement, and this steam flow measurement is also goes to the controller. That means here there are the two sensors are used. First one is used for the drum level controller, and second one is used for the steam flow measurement. So these two sensors send a signal to this two element module control system, and according to this two sensor output, it set the value of the feed water valve. So here in two element controlling, the swelling and sinking effect of the boiler drum is taken care. That means we know the disadvantage of the single element system. In a single element system, there is a limitation of the swelling and sinking effect. Now this effect is overcome by using a two element system. So here use two elements. First one is the drum element, as same as used in a single element system. Signal coming from the drum level transmitter is compared to the set point of water level, and the result is a deviation value. On the basis of this signal, the controller will generate corrective action. This drum level element is same as we know the single element system. Now here we discuss about the second one element, that is the most important. This element is the stream flow element. Here we can see this is a stream flow element. So a mass flow rate signal from flow sensor on steam outlet corrected or density is used to control the feed water flow, giving immediate correction to feed water demand in the response to the fluctuation in the amount of the steam consumption load changes. That means we discuss in the swelling and shrinking effect. That means if there is a chance, if we require more steam, so at that time steam flow rate is increased. So due to this increase or decreasing the steam flow rate, there is a chance of the swelling and shrinking effect in the boiler, and due to that the drum level water inside this drum is also changed. So to control this, module is also control the feed water valve. That means here why this system is known as a two element system, because here first one element is the drum level element and second one is a steam flow element. So here both are calculated, and according to this this two element level module is open or close this feed water valve. Now three element control system. So this above control system is not suited for a steam system where consumption is very high and fluctuating. So this is the limitation of the single element and two element system. We cannot use where the consumption is very high and fluctuating. So the three element drum level control is ideally suited where a boiler plant consists of multiple boiler, or in other words multiple drum, in case of tanker and multiple feed water pumps, or where the feed water has various variation in the pressure or flow. So if connect with the turbine, etc., sudden rise and fall of the load are very frequent. So that means in a single element and double element system there is some limitation, so it cannot be suitable for the very large plant, so where the multiple boilers are used. So for the controlling of the multiple boiler and multiple feed water pump, three element system is very suitable. So in this system there is we can see in the figure there is a three element. First one is the same as in the single element, this is drum level indicator. Second one is the same as the two element system, but here we also add one, this is a water flow. That means here we add additional signal of the water flow sensor. That means inlet water flow is also measured in this system. So that's why it's known as a three element system. Now here first one element we know the drum level element. A proportional signal coming from the drum level is drum level transmitter, and according to that the transmitting action is taken by the controller. Then second one is the stream flow element. Here this is a stream flow element. A mass flow rate signal is used to control the feed water flow, giving immediate correction to feed water demand in response to load change. That means there is a load change of the steam flow, then there is a chance of the swelling and sinking. So that's why we use the steam flow element. And the last one and most one is the feed water flow element. So a mass flow rate signal on the feed water pipe responds rapidly to the variation in the feed water demand. Any difference between a steam mass flow and a feed water mass flow into the drum is correct by the level controller. That means any difference between the steam mass flow production and this is the feed water flow. This is here is corrected by the controller by using the feed water valve. So another question occur in mind, how difference between this flow rate can arise. That means here the steam mass flow and feed water mass is arise. Difference between these two is arise because we know there are a number of reasons. First one reason is the blow down of boiler, so that's why also occur. Then leak in the steam or sudden increase in the steam consumption, so that's why we know the swelling effect. And the feed water pressure or flow fluctuation, that means a changing in the feed water pressure and changing in the flow fluctuation. That means this is a inlet flow of the water is fluctuated. So that's why we know the difference between the flow rate can arise. Now silent feature of the 3-element control system we see. So first one features is the 3-element system provide tighter control for drum level with fluctuating steam load. That means if it provide a sudden output, if there is a change in the steam flow rate, according to that immediately it changes the feed water valve. So that's why here words use the tighter control. Now second one feature is this system is ideal for fluctuating feed water pressure or flow. Then more sophisticated level of control, that means as compared to 2-element and single element control, here more sophisticated level of control is used. So this is the 3-element control system. Okay. So in this lecture we discuss about the water feeding system and controlling of the drum level. Okay.